Imagine two people eating almost the same food. One seems to stay the same weight without thinking about it. The other feels like every extra meal shows up immediately. Then there is someone who can eat enormous amounts of food, and somehow they barely seem to gain anything. So, what is going on? Why do humans have different metabolisms? Is some people's metabolism simply fast and others slow? The answer is much more complicated because metabolism isn't a single machine inside your body. It's an enormous network of processes happening every second. Your body is constantly using energy. Your heart is beating, your lungs are working, your brain is active, your cells are repairing themselves. Your body is maintaining its temperature. Even while you're sleeping, you are burning energy. And the amount of energy different people use can vary, sometimes significantly. But here's where things get interesting. Some of those differences are genetic. Some come from your body size. Some come from muscle. Some come from hormones. Some come from age. Some come from activity. And some come from your environment. To understand why, we need to go back, far back, before supermarkets, before refrigerators, before restaurants, before humans could simply walk into a store and buy thousands of different foods. Imagine a prehistoric human waking up beside a small campfire. There is no kitchen, no refrigerator, no guaranteed meal waiting nearby. Food has to be found. Maybe there are berries, maybe there are roots, maybe there are fish. Maybe the hunters return with meat, and maybe they return with nothing. For most of human history, food availability was unpredictable. Sometimes there was plenty, sometimes there wasn't. That created an enormous evolutionary problem. The human body needed to survive both situations. When food was available, it needed to store energy. When food disappeared, it needed to conserve that energy. And metabolism became one of the tools that helped make this possible. Your metabolism is essentially the collection of chemical processes that keep you alive and provide your body with energy. But different bodies don't necessarily spend that energy at exactly the same rate. Think about two campfires. One is large, the other is small. The large fire needs more fuel to keep burning. The small fire needs less. Human bodies aren't literally campfires, but the comparison is useful. A larger body generally requires more energy to maintain. A person with more muscle also tends to use more energy than someone with less muscle, because muscle tissue requires energy to maintain itself. But size isn't the entire story. Two people can be the same height, the same weight, even similar ages, and still have somewhat different energy requirements. Why? Because bodies are complicated. One major factor is genetics. Your genes influence many of the systems involved in energy use. They can affect appetite, hormone levels, body composition, how your body stores fat, how much energy you use at rest, and even how strongly you respond to hunger. This means metabolism isn't something everyone receives in exactly the same version. Humans inherit biological differences from their parents, and those differences can influence how their bodies use energy. But there is an important misunderstanding here. People often imagine metabolism as a permanent setting, fast, medium, slow, as if your body comes with a number attached to it. But metabolism is much more flexible than that. Your energy needs can change throughout your life. A growing child uses energy differently from an adult. A teenager going through rapid development has different requirements. Pregnancy changes energy demands. Illness can change them. Physical training can change them. Even periods of food shortage can change how the body uses energy. Your metabolism responds to the conditions around you, and this makes evolutionary sense. Imagine living thousands of years ago. Your body doesn't know what food will be available next week, so it needs to respond to changing conditions. When food is plentiful, you can afford to spend more energy. When food becomes scarce, conserving energy becomes much more important. Your body can adjust. It can change how much energy it uses. It can influence hunger. It can alter how much energy is stored. It can change how much you move without consciously deciding to. And that last part is especially interesting because not all movement is exercise. You might walk around your house, shift in your chair, tap your foot, stand up, sit down, change your posture, fidget. These small movements can add up. Scientists often refer to this as non-exercise activity, and it can differ dramatically between people. Imagine two people spending the same day in the same office. One sits almost completely still. The other constantly moves. They stand up frequently, walk around, move their legs, change positions. Neither person might consider themselves physically active, but their bodies are still doing different amounts of work. This can contribute to differences in total energy expenditure. And there is another major factor: muscle. Muscle tissue requires energy, so someone with more muscle mass may use more energy at rest than someone with less. This doesn't mean muscle suddenly turns your body into a furnace. The effect is real, but often exaggerated online. Then there are hormones. Your body uses hormones to coordinate energy balance. They influence hunger, satiety, growth, reproduction, stress, temperature, and how your body handles nutrients. The thyroid is especially important. Thyroid hormones help regulate how quickly many processes in the body occur. If thyroid hormone levels become too high or too low, energy expenditure can change. This is one reason metabolic differences aren't always just about lifestyle. Sometimes there are genuine biological differences happening underneath the surface. But evolution adds another layer. Imagine two ancient human populations living in completely different environments. One lives in a warm tropical region. The other lives in a cold environment. Their bodies face different challenges. In cold environments, maintaining body temperature becomes more expensive. The body constantly produces heat. In hot environments, the problem can be reversed. The body needs to get rid of heat. Over many generations, natural selection can influence traits related to body shape, size, and energy use. This is one reason human populations around the world developed different average body forms. But metabolism itself isn't simply divided into neat geographic categories. Humans are incredibly variable, and individuals within the same population can differ enormously, which brings us back to something important. There is no single human metabolism. There are millions of variations, and every person's body is a little different. Now imagine something else. Two people eat exactly the same meal. Their bodies don't necessarily respond identically. One person's muscles might absorb nutrients differently. Another person's hunger might return sooner. One might move more during the day. Another might unconsciously conserve energy. Their bodies may also digest and process nutrients slightly differently. So when someone says, "Why can't I eat like them?" the answer may be because you're not them. Your body has its own combination of genes, muscle, organs, hormones, activity, sleep, age, and environment. But there is an even stranger phenomenon. Your metabolism can change when your body weight changes. Imagine someone loses a significant amount of weight. Their body becomes smaller. A smaller body generally requires less energy. But the body may also respond to weight loss by becoming more energy efficient. Hunger can increase. Energy expenditure can decrease. Movement can change. The body essentially begins trying to defend its energy reserves. From an evolutionary perspective, this makes perfect sense. For most of human history, losing body fat often meant food was becoming scarce, and food scarcity could be dangerous. So a body that became more efficient during a shortage had an advantage. It could survive longer. But in the modern world, that ancient adaptation can create frustration. Food is no longer necessarily scarce. In many places, calories are available almost everywhere. Yet our bodies still carry biological systems designed for a world where the next meal was uncertain. This creates a strange mismatch. Our ancestors had to search for calories. We can order them from a phone. Our ancestors sometimes walked for hours to find food. We can have food delivered to our front door. Our ancestors couldn't store unlimited food in a refrigerator. We can. The biological machinery stayed, but the environment changed dramatically. And that helps explain why metabolism matters so much today. But metabolism isn't simply about body weight. Your body uses energy for much more than moving around. Your brain consumes a significant amount of energy. Your heart works continuously. Your liver processes nutrients. Your kidneys filter your blood. Your immune system constantly monitors your body. Your cells repair damage. Your body maintains its temperature. All of this requires fuel. In fact, a large portion of the energy you use every day goes towards simply staying alive. Even if you spent the entire day lying in bed, your body would still be working. This baseline energy use is called your basal metabolic rate, and it differs between individuals. But here's another misconception. A person who appears naturally thin doesn't necessarily have an extremely fast metabolism, and a person who gains weight easily doesn't necessarily have a broken metabolism. Body weight is influenced by many factors: food intake, activity, sleep, hormones, genetics, environment, behavior, and long-term changes in energy balance. Metabolism is one part of a much larger system. So why do humans have different metabolisms? Because humans are not identical machines. Evolution didn't produce one perfect body. It produced a flexible species, a species capable of surviving droughts, cold winters, food shortages, abundant seasons, long journeys, pregnancy, growth, disease, and countless other challenges. Different bodies developed different ways of managing energy. Some differences are inherited, some develop throughout life, and many are shaped by the environment. Your metabolism is the result of all of these influences interacting, which means your body isn't simply fast or slow. It's constantly adjusting, constantly responding, constantly balancing energy coming in with energy being used. And perhaps the most fascinating part is that this system was designed for a world very different from ours. A world where food could disappear tomorrow, where energy was expensive, where walking was unavoidable, where surviving winter could depend on how efficiently your body used every calorie. Today, the environment has changed, but the basic biological machinery remains. Your metabolism is still trying to answer the same ancient question: do we have enough energy to survive? And for thousands of generations, that question helped keep humans alive. So the next time you wonder why someone seems to burn energy differently than you, remember, you're not comparing two identical machines. You're comparing two incredibly complicated biological systems, built from different genes, shaped by different lives, and carrying the legacy of an ancient world. Your metabolism isn't just about calories. It's a story of survival, written into your body, and still running every second you're alive.